We have discussed some important properties of light and characteristics of the radiation of light by our sun. In this video, we will focus on converting that light to electrical energy. This is done using the photovoltaic effect. Photovoltaics covers the direct conversion of sunlight into electrical energy by a semiconductor material. The term photovoltaics is derived from the Greek word phos, which means light, and volt, which refers to electricity, specifically voltage. Volt is a reference to the Italian physicist Alessandro Volta, who invented the battery. The photovoltaic effect occurs through the generation of a potential difference at the junction of two different materials in response to electromagnetic radiation. The photovoltaic effect consists of three distinct processes. The first process involves the absorption of light, which leads to the generation of charge carriers. During the second process, the generated charge carriers are separated. The third and final process consists of the collection of the charge carriers at the electrodes. Let's look at these processes in some more detail. We will use the shown solar cell to visualize the photovoltaic effect. This is a basic crystalline silicon solar cell with an n-doped silicon layer, a p-doped silicon layer, and back and front electrodes. The first process involves the absorption of photons in the materials that form a junction. Shown here is a single photon of light incident on the solar cell. Upon absorption of the photons, an electron-hole pair is generated. A negatively charged electron is excited to a higher energy state and it leaves behind a positively charged hole. Here we show one photon of light exciting a single electron-hole pair. In reality, there will be many electron-hole pairs generated at once with a full spectrum of light. This electron-hole pair will only survive for a certain lifetime. After some time, recombination may occur. This means that the electron will fall back to its initial energy state, so the electron hole recombine. If this happens, that absorbed energy is essentially lost and cannot be converted into electrical energy. Therefore, in order to really generate electricity, we have to separate these charge carriers. How do we do this? Once carriers are generated in a solar cell, they will move around due to various processes such as diffusion, random motion, and drift. In order to separate the photo-generated charge carrier, semi-permeable membranes must be present on both sides of the absorber. This ensures that the electrons can only flow out through one membrane and holes can only flow out through the other membrane. In our solar cell here, the charges were generated in the p-type semiconductor. As you will learn in later videos, the p-n junction at the top of the solar cell only allows electrons to pass through and the junction at the bottom cell only allows holes to pass through. Therefore, the solar cell needs to be designed so that the mobile charge carrier eventually hit those barriers and are separated. So now we have generated and separated charge carriers, but we have one more step to generate electricity. The final process then involves the collection of photo-generated charge carriers. Let's start over again. Under the influence of light, a large number of charge carriers are generated and separated. The difference in the charge carrier concentrations at both ends of the PV device causes a potential difference between the electrodes. This potential can be measured by a voltmeter and is called the open circuit voltage or VOC. If an external circuit is applied between these electrodes, electrons will flow from the n-type material towards the p-type material. There is now a current flowing from a high potential to a low potential, which is the definition of electrical power. This is how the charge carriers are extracted from the solar cells. The chemical energy of the electron-hole pairs is now converted to electric energy. After the electrons have passed through the circuit, they recombine with holes at a metal absorber interface. In summary, we have seen how the photovoltaic effect involves the generation of charge carriers due to the absorption of photons at a junction of two semiconductor materials, followed by the subsequent separation of photo-generated charge carriers. And finally, the collection of the charge carriers at the terminals of the junction. In the next video, we will look at the current and voltage characteristic of a solar cell. So see you in the next video.